As most of you might know, computer networking is one of the most sought after skills in 2023. And today in this video, I'm going to help you get started in that. If you want to be an IT or if you're already having an IT career, you need to know computer networking. It's the base of every field in information technology. Just think about it yourself. You need to become a security analyst, you need to know computer networking. You want to go into the cloud, you need to know computer networking, and much more. So computer networking is the base of everything in IT, and today I'm going to be helping you getting started in that. The things that I'm going to be covering in this video will also be helping you in some entry-level certification like Cisco CCNA and CompTIA Security Plus. So stay tuned till the end of the video to get a more wider knowledge of computer networking and advance your IT career even further. Okay, so as you can see here, I have a PPT loaded up, and this is the absolute basics of computer networking. It'll take you step by step on different networking devices and how they work, and you will step by step learn the basics and how to get started in computer networking. So here we have, as you can see, basic networking devices. Alright, so basic networking devices are just basically the main devices that are used in the industry today, and that when you're doing networking physically, when you purchase network hardware, when you purchase hardware so that you can connect two machines together, like what those basic hardwares are. So these are basically in the industry, the major thing that are used in the industry today. First we have our PC slash computer. All right, so this PC computer actually does not have a network interface by itself, but it does have a LAN card inside of it, as you can see here. So it does have a LAN card inside of it, and that LAN card helps it to connect to other networks. So basically we consider this also as a networking device. When you're doing packet tracing or when you are actually simulating networks or how they work, you will be learning or you'll be seeing how a computer is basically the endpoint or the end machine from where you want to send the signal. All right. Next, we are having the LAN card. This is present inside the computer. It is also called a network interface card or an NIC. Some people might refer it as that. All right. So a LAN card or an NIC is stuck in a machine, mostly a computer, a laptop that you might have. So this computer networking card helps you connect two networks together. It's as simple as that. Next, we have a hub. A hub is basically a device. It's a rectangular device, and it has many ports in it. You will see the picture ahead. So a hub is basically used for the same purpose, for connected to two machines together, but it's a brainless device. It does not know anything. You cannot configure it. It's a non-manageable device. So once it gets a signal, it'll just broadcast it mindlessly, and it does not have any sense of whom he has to send the signal to. You'll be learning that ahead in the later slides. Next, we have a switch. A switch is a device that is used that has a brain. It looks like a hub, it has ports, but it has a brain. So let's say I want to reach another user, and like around 50 users are connected to that particular switch. So it will send my request to that particular user, and that response will come back to me. You will be learning that ahead in the later slides. Next is a router. A router is basically used in wider areas. It's used on WAN or the wide area network. A WAN or the wide area network is basically how everything is getting connected these days. So if you want to trace back on how you're getting connected to your favorite sites, let's say YouTube or Google, you can trace route that. I'll show you that in a minute. So you can trace route that, and you can actually see how many routers are there in between. So you can actually see how many routers are coming in your way when you want to reach that particular site. So next we have the MLS or the multi-layer switch. The MLS or the multi-layer switch is a very higher level networking device. So we won't be covering that in this video. It does routing and switching together. All right. So we will be learning what both of those actually mean. Switching is done by switch, routing is done by a router. It's as simple as that. Next is we have a firewall. A firewall is basically a security device. All right. Let's take an example of a very high reputed personality. Let's say Bill Gates. All right. So Bill Gates will have some bodyguards around him, right? Obviously he would. So Bill Gates would have some bodyguards around him. That's for sure. And those bodyguards that he has, let's say one day somebody tries to attack him and those bodyguards were not feeling sufficient. All right. So Bill Gates thought that he needs to appoint more bodyguards. So he added one more layer of security. Then if that was also not enough, he added one more layer of security. And that's how firewalls work. So there is a network device. All right. So let's apply this example in the world of networking. So there is a network device right here, and we are adding a layer to it. We are adding a security layer to it, and the security layer is called a firewall. It's as simple as that. A firewall, we won't be diving into that deeper because we are not doing security right now. We are just covering the basics of networking. Next, we have a basic network connection. All right. So there is one PC right here, and there is one PC right here. Right. So this is called a basic networking connection. A basic network connection is done by a UTP cable. All right. UTP is of two types, a UTP cross and UTP straight. Whenever you're connecting a PC to a PC, just remember that, just fix it in your mind. All right. Whenever you're connecting a PC to a PC, you always use a UTP cross cable. And the maximum distance that a UTP cross cable can go is 100 meters. After 100 meters, the signals start getting weak and the UTP cross cable does not work that much properly. So that Ethernet thing that you use, that is of two types. All right, that is the UTP cable, and that is of two types, UTP cross and UTP straight. So you're connecting a PC to a PC, so you're using the UTP cross cable. Just fix that in your mind. All right, just fix it. Next, we have a hub. We'll be diving deeper into a hub. A hub, as you can see, it's a network device. We all know that. All right, it's a hardware device. We all know that. We are not doing anything software here. We have a physical device. All right, we have a physical device called a hub, which has a lot of ports. We can connect our devices to that ports so that we can establish a connection between them. All right, it's non-manageable. We know that. Next, with the help of hub, we can create a LAN setup. All right, a LAN setup is basically a local area network setup. Got it? So let's say we have a computer machine connected here. We have one here, one we have here, one here, one here, one here. All right. So this is how a hub works. I'll just explain it to you how it works. These are the devices connected to my hub. All right. Let's just name them 1, 2, 3, 4, 5, and 6. So 1 wants to send a signal over to 4. All right. And it needs the help of a hub to do it. It has a hub and it sends the signal, it sends the message that it needs to send to 4. All right. The hub takes it inside, does not process anything. It does not process anything. It's absolutely null. It's brainless. So 1 sends a signal, 1 sends a message to be reached to 4. And the hub, what it will do, it will broadcast the message to every single device that is connected. It will send it to 1, it will send it to 2, it will send it to 3, 4, 5, 6, it will send it to every device that is there. That's why hub is called a brainless device. Even if it is specified in that file that it needs to go to 4, hub will not think. It will just spit it out to every single device that is there. And once it gets rejected by all the other devices and 4 says, yes, this is my packet, I want this packet, then the hub gets to know, all right, that 1 needed to send a packet to 4. Still, again, if 4 sends a packet and it's for 1, it will not think again. It will just broadcast the message. All right. With hub, we can connect within a network. We know that. All right. Within a network, we can connect into a hub. It's a brainless device. And when any PC is connected to UTP straight is used. All right. So I told you that whenever a PC to a PC is connected, we use a UTP cross cable. And whenever a hub to a PC is connected, we use the UTP straight cable. Whenever any network device is connected to a PC, we are using a UTP straight cable. It has a very deeper meaning into that. Don't just dive into it. Just for now, learn that a PC to a PC, when it connects, UTP cross is used, and whenever any network device is connected to a PC, UTP straight is used. Next, we have the switch. All right, so the switch is an intelligent device. It looks exactly like the hub only. All right, it does not have any change. It has ports like that. It looks like a rectangular device. All right, so again, we are connecting 2-3 devices here. All right, we have 2-3 network devices here, as simple as that. It is a manageable device. I should add, it's a manageable device. All right. So whenever you are doing things with packet tracer, you can manage it. All right. You can tell it, you can apply commands into packet tracer and it can actually comprehend what you're trying to tell it. All right. Then it is a data link layer device. There is a OSI model. There is a OSI networking model. If you want to know more about that, you can just search in the net. You will get thousands and thousands of results. But actually in this video, I won't be doing that. I would be doing that in my next network video because it's actually a very deeper topic and we should not leave it like that. So just think, there is an OSI model. It has 7 layers, which includes one layer that is called data link layer. It's layer 2, and this is a layer 2 device. It's a data link layer device. All right. Then we can create a LAN setup with this. All right. It's as same as the hub, but it has a brain. All right. Then we have works on the same subnet. This works on the same subnet. Our same subnet is, let's say this is the IP address 192.0.0.1/24. Alright, this is the IP address. Same subnet means that this last octet will be changing. Alright, these three octets will remain the same. This last octet will be changing. So that means it's in the same subnet. It learns MAC addresses. We'll be learning what is MAC addresses just in the next slide. It learns MAC addresses. It learns physical addresses. Alright, so let's see what a MAC address is. A MAC address, what is a MAC address? Alright, a MAC address is a 48 hexadecimal number. Don't be, so perplexed with this, all of this. It's just a number, alright, that is assigned to every computer. Alright, so if I want to send a parcel to you, I would be needing your address, right? So it's same with computers. If one computer wants to send something to another computer, it needs an address. And this MAC address is pre-built when you get a computer. It's pre-built into your LAN card. It burnt into your LAN card, alright? And IEEE is an organization, Institute of Electrical and Electronics Engineers. Alright, so IEEE, this is an organization, and this deals with all the MAC addresses that are ever there, that are there in the world. Alright, this created MAC address for the first time, and it has been doing that ever since. Next, to get MAC address of a computer, we just have to type get MAC on the command prompt. Alright, so if you're in Windows, you just go on a command prompt and type the command get MAC. Alright, and you will be getting your PC's MAC address. If you are in Linux or in Mac OS, same, go on the terminal and just type get MAC. Alright, you'll be getting the MAC address of your machine. So as you can see, this is how it looks like. I hope you know what a hexadecimal. Hexadecimal goes from 1 to 9, and then from 10 to 15 it takes A, B, C, D, E, F. Alright, so it takes 5. So it's 1 to F. Alright, actually it's 1 to 15. So this is how hexadecimal works. It's actually mathematics, but we are not going into that. Just remember that MAC address is a hexadecimal thing. It is of 48 bits. Every single character is of 4 bits, and it has 12 characters always. It has 12 characters. Always it will have 12 characters, and 4 into 12 is 48. So that's why it has 48 bits. Next, we have a router. Router is actually a more modern thing. It is used in our day-to-day lives. Router is a very important thing that are used in our day-to-day lives. All right. Router is a very important thing. If you are trying to connect to any server right now, you'll be doing that through a router only. A router is a network layer device. It is a hardware device. Alright, network layer. Again, OSI model, network layer. Then it's a hardware device. It's not a software. We can use it. We have to use it physically. Then it works on IP addresses. So we learned that switch works on MAC addresses, and a router works on IP addresses. Alright, so IP address is basically again another address of the computer, but it's on a network. And because MAC addresses are physically burnt into it, and IP address can be changed, and it is assigned to a machine, it is assigned to a laptop, it is assigned to a PC via the network. Next, we have works on different subnets. All right, so a LAN setup works on the same subnets, and a switch deals with the LAN setups, and a WAN setup or a wide area network setups works on different subnets. So let's see, this is a switch right here. So yeah, let's see, this is a switch right here. All right, and this is also a switch right here, and this is a router. All right, so it has a LAN setup. This is a LAN setup. All right, this right here is a LAN setup. Let's take it LAN 1, and this right here is also a LAN setup. Let's take it LAN 2. So this router right here is connecting LAN 1 to LAN 2. All right, this is a LAN setup. Here it is working on MAC addresses, but once it reaches here, this will take its request in IP addresses. It will learn these switches as IP addresses, and it will learn these switch will learn these PCs as MAC addresses. Next, we have topologies. Topologies is actually a very integral part of computer networking these days. And computer networking, you can say topologies are basically a physical way to represent a network. All right, how you are connecting the machines that you have. So we have bus, we have ring, we have star, extended star, and mesh topology. These are 5 of the main topologies that are there. Some of these are outdated, and only 2-3 are working in the industry these days. So we have the bus topology first. The bus topology, as you can see, has a single backbone cable. This is one cable, and all the computers are connected to this cable. So let's see the disadvantages of this. All right, so this cable, let's say it fails one time, all these machines will stop. The network will collapse at that very second. You won't be able to do anything if that backbone fails. All right, so this is the disadvantage of bus topology, and the advantage is that you can connect and you can remove devices very easily. So if you remove this device, it won't affect the network. If you add some device here, it won't affect the network. All right, so this is very advantage and disadvantage of this topology. This cable is called a coaxial cable. All right, it's an outdated topology. You won't find it anywhere in the industry these days. All right, next we have ring topology. Ring topology is actually absolutely the same, but it is connected. All right, we have everything in a ring shape, and the signal can move via a ring, but it has a lot of disadvantages. If one computer fails, the network will be disrupted. If this wire fails, the full network will be gone. All right, so these are the disadvantages of this ring topology, and it's yeah, it that this is also not that efficient. All right, it also won't does not work in this day to day. It is not. It is a very outdated topology. Next we have star and extended star. All right, this you will be able to find in some industry. This is, this is a topology that is used. All right, so there is a hub, there is a switch or hub in between, and it is supposed to be a switch or hub only. It cannot be a router. We have machines here and we have a hub in between. This is a star topology. All right, so you can add, you can remove very easily. If one device fails, it will not affect anything. It has different cables for every devices. So this is how it works. These are the definition. If you want to read it, you can. Extended star is basically a more efficient version of a star topology. It has one in between and it has a few more at the end, and then the machines are extending from that. It's basically extended, is basically the extended version of this. Now this is the most important topology that is used, and it is the most used topology in the industry today. All right, so this is called the mesh topology. If you want to read this, you can. Mesh topology, I'll explain it to you. So let's take one computer here. So these are named 1, 2, 3, 4, and 5. So let's say this connection right here, this connection fails, and 5 wants to connect to node 2. How will it do it? It can go like this, it can go like this, it can go like this. It has n number of ways. If any of the wires fail here, all right, let's say this wire fails, and this computer wants to connect to this computer, it can go like this, right? If it wants, it can go round like this, right? So this is the mesh topology. All right, so it has plenty of ways to go. Every computer is connected to every computer in one or the other way. So let's see, this computer is connected to this, it's connected to this, it's connected to this, and it's connected to this. This is connected to this and this. So it works like that. All right, so every computer is connected to every computer, and even if two fail, even if two connections fail, even if three connections fail, the entire network won't collapse. And this is the modern way. This is how actually industries are working on this topology, on the mesh topology. So that's it for this video. And if you liked it, please don't forget to smash that like button, subscribe to the channel, and I will be continuing this series of networking. And this is the base of all the entry level certifications, as I told in the introduction. It's the base of CCNA, it's the base of CompTIA Security Plus. So if you're aiming for the certification, this video is really going to help you. And the next video that I'm going to be putting up is a continuation to this course, continuation to networking. It's basically just CCNA or Security Plus. It's just I'm following the syllabus of that. It's a structured way, and I'm going to be putting a few more videos in this series. So be sure to watch them, and I'll catch you guys next time.